All right, girls, this video is going to help you with lesson 2, which talks about thermal energy transfers. So remember, match up the headers in the book if you're trying to figure out where I'm getting the answer. So in the textbook, this is a red header, how is thermal energy transferred? So the first question says, identify 3 ways thermal energy is transferred. And the way that transfer is being used in this sentence means moved, or how it can move. Transfer can mean a lot of things, but in this sentence it means how does thermal energy move. So thermal energy can move from one thing to another through radiation, conduction, or convection. And one thing that you should remember from section 1.1 when you're reading section 1.2 is heating. So heating is actually when thermal energy moves from something that's warm to something that's cold, and it keeps moving until both of the things are the same temperature. So when we're thinking about radiation, conduction, and convection, you usually have the thermal energy moving from something that's a part of the liquid or something that's warm to something that's cold, and it'll keep moving until the two things that are in contact or the fluid is the same temperature. Next header, radiation. Characterize radiation. So just they want you to know some basic information or characteristics about radiation. So radiation is the movement of thermal energy by electromagnetic waves. So I substituted moved for transfer. And radiation can happen through a vacuum. So a vacuum is where there's not a lot of matter. So in outer space, there's not a lot of matter to actually that can be used to transport or move energy, and it can happen in solids, liquids, and gases. And just electromagnetic waves, they're waves of energy. So this is a wave. They have an electric field and a magnetic field, and they can carry energy. And remember, one really important thing to remember here is Earth gets its heat from the Earth is heated by the sun. So the sun gives us thermal energy by sending electromagnetic waves or electromagnetic radiation. The next one is conduction. Describe conduction. So once again, they just want you to know some basic things about conduction. Here is the definition. So I'm going to substitute the word moved. So the movement of thermal energy by collision of particles. And this word right here, collision, the root word is collide, and collide means to hit. So the particles of one material or one liquid or one gas hit the particles of another. And this can happen in solid, liquids, and gases. So we have all these different states of matter that have particles, and these particles can hit each other, and they can thermal energy can move from one to another in that way. All right, contrast. The word contrast means to tell the difference, and I'm still under the same header, conduction. Contrast means to tell the difference. They want to know the difference between the conduction and specific heat of thermal conductors and insulators. So remember, a thermal conductor is a material that can transport thermal energy easily. Thermal energy can move through it easily, and a thermal insulator is a material where thermal energy does not move through it or cannot be moved through it easily. So that's when we were talking about ease of conduction, and conduction just means movement, how easy they can move thermal energy, or how easy thermal energy can move through it. So conductors easy, thermal insulators not easy. And insulate, like in, means you want to keep it inside. Relative specific heat. So thermal conductors usually have low specific heats. It doesn't take a lot of energy to heat them up, and that makes sense because thermal energy can move through them easily. Thermal insulators usually have a high specific heat, and that makes sense because it's hard for thermal energy to move through them. And the reason why the electrons move through it easier, and electrons cannot move through it easier. So I have a little diagram over here that explains what they mean by electrons and why that matters. So let's say that this is a tube, and this is a solid block of something, and it's made of a material that's an insulator. So let's say it's made of wood. Let's say this is a wooden block. So all matter is made up of atoms. So these are the atoms that are in this block of wood. Since it's an insulator, The electrons, so here we have our nucleus and our protons, and then you have your electrons on the outside, two different atoms, a whole bunch of atoms, but here are two of them. The electrons are actually what carry the thermal energy. When we talk about the particles, we're talking about the kinetic energy of the electrons. We're talking about the potential energy of the electrons. And so the electrons in insulators, they can't jump from atom to atom easily to pass that thermal energy. But in a conductor, it's made of, and this is like let's say that this is an aluminum block, or this is a copper block, or something like that, some kind of metal. These electrons that carry the kinetic and potential energy can jump from one atom to another, which means that they can pass the thermal energy very easily. So that's what they mean, that electrons can or cannot move through a material easily. The next thing, thermal expansion and contraction. So this is talking about hot air balloons, which isn't really important to know. It's just important that you know what thermal expansion is and what thermal contraction is. So that's when an increase in volume when it's a material that increases in volume when the temperature increases, or a material that decreases in volume when the temperature decreases. So you can look at this and you can read it on your own. And if you wanted more information, just a reminder about what density is and how that relates to volume, take a look at this. So we have two blocks. So density is just how much mass you have in a given volume. So the volume is the inside of this cube. That's how much space there is to be taken up. And this gas would actually have a low density, because it doesn't take up a lot of the space. This gas would actually have a high density because it does take up a lot of the space that's inside of the cube. And how that relates to hot air balloons, when you heat up the air in a hot air balloon, it goes through thermal expansion, and that makes the balloon rise because the balloon becomes less dense. It takes up less space than the air on the outside, so the balloon will rise. But if you cool off the air inside a hot air balloon, it's going to go through thermal contraction, which means that the balloon will become more dense than the air outside of it, and it'll fall. And it's just remember to understand that it's the air, not the balloon, that's going through thermal expansion and thermal contraction. So you won't actually see the balloon shrink or expand. It's the air inside it that's actually doing the shrinking, the expansion, and the contraction. And the last thing, convection. They want you to characterize convection. They want you just to know some basic information about convection. So once again, a definition. This says transfer, but I'm using the word movement of thermal energy by movement of particles from one part of a material to another. So this is within one material. So when we talk a lot about the things that are in contact, like when we were talking about radiation, when we were talking about conduction, you actually needed things to touch, or you needed two things to touch or contact each other, but not really for radiation, because it starts at the sun, it travels on a wave, and then it hits something else. But for convection, it's all within the same material. And these materials can be liquids or gases. So remember that it has to be a fluid, so that means it can be a liquid or a gas. And this is the movement. Yeah, we already went over that. So they want you, so this was just some basic information about convection. And once again, I don't think there's anything that I want to add to that, but this is just basic information about convection. Now this is explaining atmospheric convection currents. So atmosphere means the gases that surround the gases that surround the earth, and convection currents. So the gases that surround the earth, these gases that we breathe, those actually help control Earth's temperature. They actually help, they're what determines Earth's temperature. So warmer, less dense air heats up. It becomes less dense and rises. So in the textbook, they show you the equator, and the equator is the hottest place. Places around the equator are the hottest because they get direct waves of electromagnetic radiation from the sun, and they rise, and then they reach a certain point, they reach a certain latitude or longitude point, and they cool off and they become denser, the air becomes dense, and when it becomes more dense, it sinks. So let me actually show you what this looks like in the textbook and how it can help and how it actually controls the temperature of the earth. So you have direct rays of sunlight, you have hot air. You have the hot air. The hot air is going to rise, but then when it reaches up here where it's cooler, it'll sink, and you just have these convection currents. These convection currents that actually help warm and cool the earth. And those convection currents are just like this convection that you see in this beaker. So you have the cold air sinking, you have the hot particles or cold, you have the cold particles sinking and the hot particles rising. Cold sinking, hot rising. And that's the same thing that's happening here, but it's with air.